Hello and welcome to the second PressurePro tutorial. In the first movie we covered data import and model building. We will now dive straight into the pore pressure model building. The model building process works according to the workflow shown here. First we build an overburden model, pick our true shale points, define a fracture gradient model, and then we'll pull these various elements together into the pore pressure model. Open the project saved from the first tutorial and click on the PressurePro button on the home view. The first thing we should see is that well 1 has multiple sonic curves and they're all the same colour. Click on the curves button on the left and change the colour of the compressional sonic and make the second curve invisible. We can then see that our gas and ROP data is very low and is labelled in feet per hour and US units respectively. This data is in percent and meters per hour and could have been set up correctly when we were importing. We will now see how to fix this problem if that step was skipped. Go to the Curves button on the top ribbon, double click on the units and select the Advanced option. Select the source units and destination units as the percent for the gas and meters per hour for the ROP. We now need to change the scales as well, so click on the Curves button and change the gas scale to 0 to 20% and the ROP from 0 to 100. As you can see, even if mistakes were made when importing data into the software, flexibility exists to allow us to fix any errors. Now that our data is correct, let's start the pore pressure model building process. Click on the pore pressure model settings button. The initial view shows basic model settings such as a fill gaps option should there be any missing data so that the software will interpolate between data points, and options for changing the regional hydrostatic pressure and flow line height. The default settings should work in most scenarios. Before we start the process, make the density track visible using the Tracks button on the left and zoom in on the log to find out the depth of the first density reading. The depth will be shown in the bottom left corner, which in this case is 522 meters. Now click on the Overburden button. We have two options available. Click on the Wizard button. This now gives us three new options. The supplied option allows the importing of an existing overburden curve rather than building a new one. The other options allow calculation from a density or sonic curve. In this tutorial we'll use the density curve. Either double click on the density option or click to highlight and click OK. The next step of the wizard allows us to select a density curve that is already loaded in the model or to load a new one. As we already imported all our data, select the Use Existing option and select the curve. Now we define the air gap of sea level or ground level to rig floor. As we entered all our data in, this populates automatically, so just click OK. As these wells are offshore and we entered a water depth, the wizard prompts for a water density for the fluid column down to the mud line. The default is set to 1.025 grams per centimeter cubed, which can be changed in case of regional variation. Click OK. The next element of the wizard is where we define a linear density increase from seabed to our first density data point. We use regionally known density trends to assign these values. We will assign the bottom depth as 520 meters, which is where our density data starts. For the top density, which is at seabed, we will use 1.75 grams per centimeter cubed, and for the bottom, 2.2 grams per centimeter cubed, as that is the approximate value of our first density point. As you can see on the plot, the overburden curve has been created. Now let's go back to the overburden dialog box. We can see the various elements of the overburden curve grouped into a tree structure. Clicking on the manual button will create a new overburden. This demonstrates how to build a manual model, but we recommend using the wizard to guide through the steps. If any element requires changes, simply click in the appropriate cell to change the values. This multi-model method does allow for various overburden curves to be tested with well data in order to calibrate to existing well data should the regional overburden gradient be unknown. Close the dialog box and click on the Display Pressure button. The absolute pressure track will toggle between showing the actual absolute pressure or the pressure without the regional hydrostatic pressure so that just the overpressure is shown. This concludes this tutorial. In the next tutorial we will look at shale picking.